Welcome to our YouTube channel. Okay, today's lesson is based on physics, which is the topic waves. So on this topic, we've got different types of waves. We've got longitudinal wave, transverse waves, sound waves, EM waves, which are electromagnetic radiation waves. Okay, then looking at a wave, there's what we call pulse. So we're saying a pulse is a single disturbance in a medium, e.g., spring or rope. And then on that wave, we've got what we call a pulse length, which is from one end to the other. When you disturb a rope, there's a movement that comes from one end to the other. Then the direction of pulse, we call it the direction of propagation. Then that direction of propagation you're seeing is when the distance is perpendicular to the direction of the pulse that is moving. That is a transverse wave. So on that pulse, we've got also what you call the pulse length. We use delta t, which is change in distance. Then the pulse length you are seeing is the distance from the point where the displacement starts to the point where the displacement ends. That's pulse length. Then the SI unit for that pulse is in meters. So the pulse length is measured in meters. So you might be given your pulse length in different measurements. So you should know that you need to convert to meters when you're calculating. Okay, so looking at this diagram, we are looking at this starting point to this ending point. So this is the pulse length. And then the distance from this position, which is the rest position or point of equilibrium, to this part, that is the crest, the peak of the pulse, which is the crest. So if you go down, this is the peak at the lower part of the pulse, which is the negative, which is called the what? The trough. And if you look at the distance from this, where the pulse starts and where this other pulse end, is called the wavelength. Then it continues to another. Okay, so you see we have that peak point that we were talking about, which is the amplitude of the pulse, which is the maximum displacement from the position of equilibrium or point of rest. So you're saying the amplitude is measured in meters or centimeters. Then we need to check the pulse speed. Remember, this pulse is moving, so use a formula. Pulse speed is equal to distance covered over time taken. So our pulse speed is represented by v. Our change in distance is delta t over our time in seconds, which is delta t. Okay, then on those waves, we've got what we call interference. Remember, you've disturbed the spring on the rope, and we're saying whenever two pulses in the same medium meet, they will interact with each other. That interaction is known as what we call interference. So the interference is the overlapping of two pulses that are at the same point at the same time. Now let's look at the effects of interference. How does the effects of interference show us? So they can strengthen the pulse. It can become stronger, meaning it can cause a greater amplitude, so it will form a bigger amplitude. They can cancel each other, causing a lower amplitude. Then now looking at the interference, those two pulses, they meet at a certain position, which is called the superposition. So you're saying the definition of the superposition is the algebraic sum of the amplitude of the two pulses that occupy the same space at the same time. So that meeting of those two pulses at the same time is also known as the superposition. Okay, then all those two types of interference, there is what we call destructive or constructive interference when they meet at the superposition. So you're saying constructive interference when two pulses meet at the same time, creating a greater amplitude. Then destructive when two pulses in the opposite direction meet, creating a lower amplitude because they'll be in different amplitudes. And then let's look at the constructive interference. So these are two pulses that are moving in different direction. This one is going to the right, this one is going to the left. So when they meet, during meeting, that's the superposition, they form a greater amplitude. Then after meeting, they go back to their original direction in their original amplitude. That's constructive. Then destructive interference, the other one will be in the positive, so it's moving to the right, but in the positive direction, so it's moving to the left in the negative direction. So this is before. So when they meet during their superposition, yeah, these ones, if they have the same amplitude, they give us a straight line, or they cancel each other to become a straight spring or a straight rope that is moving. Then after the meeting, they go back to their original movement. This one continues in the positive direction, this one continues into the negative direction.